morning to all. I am A.V. Laxman Rao, Assistant Professor in Physics, Department of H&S. In today's session, I am going to explain you about what is a free electron theory of metals. See, in this session, I am going to explain you about two important electron theory of gases as classical free electron theory of metals and the quantum theory of free electron theory of metals. So about metals, how that metals will have high electrical conductivity. What is the reason behind having the high electrical conductivity by the metals? That theory I am going to explain in this session. And also we are going to discuss about the success and failures also. Now, if you take the classical free electron theory, first I am taking the classical free electron theory, and by using that classical free electron theory, how the metals will have high electrical conductivity, I am going to explain. For example, if you take two different types of materials as conductors and insulators, if you take two different types of materials, conductors and insulators, what is the difference between these conductors and insulators? In general, we can say that conductors are also nothing but metals. Conductors are also called metals, such as examples we can take as aluminum, copper and steel. All these are examples like that we can take, which are also called as metals. In conductors or metals, the main property about the electrical conductivity is here current will flow easily in conductors. It is nothing but electrical conductivity in conductors is very high when you compare with the insulator materials. Insulators examples we can take as cloth, we can take wood, we can take rubber, glass, as like that we can take. Now the thing is, when you compare the conductors with insulators, conductors are having high electrical conductivity. In 1900, nobody knows that why the conductors will have high electrical conductivity when compared with other materials. The theory which was explained, the first theory which was explained about this is classical free electron theory. In today's session, you are going to know about what is classical free electron theory and what is quantum free electron theory and the successes and failures of this theory. Now, to know about this theory, first we must know about electrons in a material. We know that every material is made up of here atoms. In atoms, we know that electrons are the charged particles. The importance of these electrons is they are controlling or governing the entire properties of that material. So, electrons are playing an important role in deciding the properties of a given material. So, the properties of any material can be said as here electrical properties, thermal properties, and we can take magnetic properties and all other properties. So, any property you take of any material which are governed or controlled by electrons only. So, how these electrons are contributing in deciding the electrical conductivity of metals, now we are going to see. Okay. Now, first let me take the first theory. Two theories are there as I told to you. First theory is classical free electron theory. According to this theory, how in metals electrical conductivity is very high. It was explained as like that. Okay. Now, you see, in the year 1900, two scientists called as Drude and Lawrence. These two scientists were proposed this theory. This theory is called classical free electron theory or classical free electron gas model also we are calling. The reason for calling this as a gas model, that also I will tell at last. Now, here, according to these two scientists, if you take a metal, for example, you take a metal. Metal is nothing but a crystalline solid that we know. What is a crystal? A crystal is nothing but a solid material in which atoms or ions are arranged in a systematic manner. Atoms or ions are arranged in a systematic manner. For example, you take any metal which is also called as a crystalline solid in which atoms can be expected as they were arranged in a systematic manner. And not only this property, one more property that here atomic arrangement is systematic and the pattern whatever is there, it is of repetition. Repeating pattern will be there. So, here in this region, how the atoms are arranged, you take within the metal some other region in which also the same atomic arrangement can be expected. Atoms are arranged in a systematic manner, and the pattern is going to be repeated and again in crystalline solids. Metals are crystalline solids in which atoms are arranged in a systematic manner as like that. Now here one more important property of metals is metals will have low ionization energy. Metals will have low ionization energy they will have. What is this ionization energy? It is nothing but the minimum energy that is required to release an electron by an atom is called ionization energy we are calling. In general, at room temperature itself, these atoms in that metal will release the electrons. So blue color whatever I have taken here as circles, these are called as the electrons, and whatever the round that big circles are there, they are nothing but the ions. By losing the negatively charged electron, now this atom here have become as an ion, and all these blue dots are nothing but they were called as the free electrons we are calling. Now according to this theory, if you take a metal consists of a large number of free electrons. This theory was proposed as like this. Assumptions. These assumptions are made by these two scientists in the year 1900. Soon after the discovery of this electrons, this theory was proposed as like that. If you take a metal consists a large number of free electrons, and these electrons, blue color whatever the dots are there, these are nothing but the free electrons which will move freely and randomly within the metal. So a large number of free electrons are there in a metal, and these free electrons can move freely and randomly within the metal. So here how much freeness they will have? It is equivalent to the freeness of a gas molecule in gas container. That much freeness they will have. That's why this theory is also called free electron gas model we are calling. In gases, how freely that gas molecules in a container will move, that much of freeness these free electrons will have in metal. Hence, it is called free electron gas model. We are also calling it as. That is the reason behind calling the free electron gas model. Now, very important thing is here all these positively charged ions at whatever are there, they are immobile ions. Immobile ions is nothing but they will not move. Only the movement will have for the free electrons only. And the energy lost due to these free electrons when they were moving from one place to another place, there is a possibility that one free electron will collide with another free electron, but this collision is negligible. As like that, these two scientists were proposed a theory about the metal. So overall we can say that a metal consists of a large number of free electrons, and all these free electrons can move freely within the metal, and as well as randomly they can move, and the freeness of these free electrons can be expected as is equivalent to the how in a gas molecules will have the freeness. That much freeness they will have, and the collision between one free electron to another free electron is almost can be expected as negligible, and all these positive ions are immobile ions. As like that, they have proposed one theory. Now, according to this classical free electron theory, what will happen when electric field whatever you are applying on these metals, then that we will see now. Now, when applied electric field, external electric field whatever you are applying, let us assume that is 0. When you don't apply any external electric field, all these electrons will move freely and randomly. Due to that, the velocity vector is becoming as 0. Due to that, no electrical conductivity can be expected unless until you apply electric field on that metal. Now, when you apply electric field, this diagram is about when you apply electric field, then how the free electrons are moving from one place to another place. Now, you see, I am applying the electric field in this direction. I applied electric field is right to left you take. Then what will happen due to applying of this electric field? Here these electrons, whatever electrons are there as the free electrons, they will experience a force. Due to experiencing of a force, they will start moving from one end to another end. In general, when you apply electric field in this direction, in opposite direction, the force is going to be experienced by the free electrons. Due to this force, they are getting some drift velocity. Due to this drift velocity, all these free electrons will move from left to right. Right to left, we are applying the electric field, and the free electrons are experiencing force from the left to right. Due to that reason, drift velocity, they are acquiring some velocity called as drift velocity, and the velocity vector due to this momentum is a huge value we are getting. So if drift velocity value is very high, we can say that the electrical conductivity in that metal or the material will also be high only. That's why in metals, when you apply electric field, due to the motion of electrons in the opposite direction of applied electric field, high drift velocity we are getting. Due to this drift velocity, it is resulting high electrical conductivity in metals. Like this, these two scientists were proposed or assumed about the electrical conductivity of metal. Now, here some important terminology that you must know when we are discussing about free electron gas model. Now, the first one is, what is drift velocity? As I told to you, when we apply electric field in one direction, electrons are experiencing the force in the opposite direction. Due to this opposite direction experiencing the force, all the electrons are moving in opposite direction, in unit direction. Then the velocity whatever they have acquired is called drift velocity, and we are representing that drift velocity with Vd. So that is the drift, about the drift velocity, the definition. The second one is collision time. When the free electrons are moving from one place to another place, obviously they were going to collide with the positive ion sides, and also can be expected that one electron is going to be collide with another electron. Now, how much time taken for the electrons between two successive collisions? Between two successive collisions, that time is called the collision time. In general, collision time is represented with a symbol that is tau. It is not a t, we are calling it as tau. Collision time in free electron theory gas was given as the tau, symbol as a tau. Now, the third one is about mean free path, which is called mean free path. It is the average distance. When you apply electric field, electron is moving from one place to another place. The average distance traveled by an electron to reach from one end to another end. That average, distance which it was traveled in angstrom units or nanometers, that distance is called mean free path, we are calling it as, and we are representing that mean free path with a symbol that is lambda. We are representing with lambda. Next one is very important, that is mobility. Mobility of electrons. It is nothing but they are moving. Momentum of electrons action. It is the ability of that electrons, charge carriers, here are the electrons. It is the ability of charge carriers to move freely from one end to another end in a metal under the influence of external electric field E. That is called as the mobility, and we are representing that mobility with a symbol that is mu. So, mobility is nothing but the ability of that electron or the charge carrier move freely from one end to another end under the influence of applied electric field E. So, these are very important terminologies when we are discussing about that classical free electron theory. So, if you know about these four important terminologies, then how these two scientists were derived expression for electrical conductivity, that will become as easy to understand. Let us see the equations that they have derived about the electrical conductivity of metals. So, according to this theory, the RMS velocity of electron, in general RMS velocity of gas molecules we are taking, but the thing is here electrons are behaving as the gas molecules. So, the RMS velocity of electrons is equivalent to the RMS velocity of gas molecules. Whatever the equation there we have written, the same equation can be written for the moving electrons also. RMS velocity of electrons, that is C bar, can be written as under square root of 3 kBt by m, where kb is nothing but the Boltzmann constant, T is absolute temperature of the material, that is nothing but the metal, and m is the mass of moving particle. Here is the electron. Now, the second equation is very, very important. According to this theory, the electrical conductivity is represented by a symbol that is sigma. So, the units of this electrical conductivity sigma are per ohm per meter. In general, we will write units for this electrical conductivity sigma per ohm per unit per meter. Now, according to this theory, sigma is written as Ne square by m into tau. So, what is N? N is nothing but the number of free electrons available in that metal for electrical conductivity, and E is the charge of electron, and T is nothing but called as the collision time. T is collision time, and N is the number of free electrons in that metal, and m is the mass of that electron. By taking these four, one is N, second one is E. E is nothing but the charge of electron, and by taking these four parameters, here they have written as sigma equal to Ne square by m into tau as like. So, the same electrical conductivity in terms of mobility of charge carriers in metals, how we can write that is sigma is equal to Ne into mu. We can write it as Ne into mu, where mu is nothing but mobility of electrons. Now, here one more important equation is there. According to the classical electron theory, the current density J is nothing but current density, and J can be written as minus NeV. V are nothing but here Vd also we can take. V is nothing but velocity of electrons. By applying electric field, charge carriers as electrons are experiencing force and they are acquiring the velocity. That velocity is nothing but drift velocity. So, N into E into Vd, if you multiply these three parameters, then you will get the current density value. Here, the reason for writing the minus symbol is nothing but when electrons are moving in one direction, the current in general will be taken is the direction as the in opposite direction of the flow of electrons. That's why here to represent that direction of flow of electrons with respect to the direction of flow of current, here we have taken as minus. So, another equation can be written. It is nothing but also called as Ohm's law. We are calling it as Ohm's law in terms of current density have been written as like this. Now, the same electrical conductivity sigma, if you want to write in terms of lambda, lambda is nothing but here mean free path. If you want to write, then it can be written as Ne square into lambda by under square root of 3 kb. Kb is Boltzmann constant, T is absolute temperature, and m is the mass of that electron. As like this also we can write. In different ways, we can write according to this theory the electrical conductivity value. 1 is this one, 2 is this one, 3 is this one, and 4 as like this also we can write. So, the current density here can also be written as J equal to sigma into E, as like this also we can write. So, these are all the ways how we are writing the current density and the electrical conductivity of a metal according to this theory. Now, as I told to you, this theory after proposed by these two scientists, it was observed that this theory was successfully explained about some phenomena, and it could not explain about some phenomena. We are calling them as the failures. First, let us take the successes of classical free electron theory. So, if you take this success of classical free electron theory, we can say that whatever the Ohm's law is there, that also can be proved by using this theory. So, Ohm's law can be proved or valid by using this theory. And the second one is this theory was successfully explained about metals electrical conductivity and as well as the thermal conductivity. Sigma is conductivity, E is nothing but electrical conductivity. And if you write sigma followed by T, it is nothing but thermal conductivity. So, these two phenomena were successfully explained by this theory about the metals. And third one is optical properties of metals are also successfully explained by using this theory. So, that is also very important. Optical properties are also explained successfully by using this theory. And very important, Weidmann-Franz law, that is the relation between the electrical conductivity and thermal conductivity, can also be derived by using this theory. All these are the successes of this theory. But let us see what are the failures of this theory. So the first failure is, according to this theory, we know that sigma is given as directly proportional to n. Sigma is directly proportional to n is nothing but if more and more number of free electrons are there in a metal, then its electrical conductivity should also be high only. But practically it was observed that few monovalent metals have high electrical conductivity than the divalent metals. Monovalent is nothing but one valence electron only it will have. So one free electron it is having, but divalent is having two. Though it is having two valence electrons, some of the metals or materials electrical conductivity is observed as reverse manner. So why it's so happening in these materials, this theory unable to explain. That is the first failure of this classical free electron theory. According to this theory, sigma is directly proportional to n, but in some cases we cannot take as like this. And the second one is temperature dependency of resistivity of the metals is also not explained clearly by this theory. For example, you take resistivity as a rho. If you take, rho is directly proportional to the temperature. If temperature varies, resistivity will also increases. If temperature increases, resistivity of metal will also increases. But when you take the low temperatures, the same relation is not applicable. Here the resistivity is directly proportional to T to the power 5 in metals. Why it's so happening? This theory could not explain. That is another failure of this theory. And this theory, by using this theory, we cannot explain about a phenomena called superconductivity. And also in insulators, why electrical conductivity is 0, this theory could not explain about these two things also. And very important thing is, the mean free path of electrons could not be predicted correctly by using this theory. Average mean free path only can be calculated, but exact mean free path of that electron we cannot calculate by using this theory. And another failure of this theory is, some phenomena you take as photoelectric and the Compton effect and black body radiation cannot be explained by using this theory. These are all nothing but the failures of this theory, classical free electron theory. Now, how to overcome these failures? We need to propose another theory. That theory what we are calling right now is called as quantum free electron theory. We are calling. We have two different types of free electron theories: classical free electron theory and quantum free electron theory. Quantum free electron theory was here we are using to overcome the failures of the classical free electron theory. This was proposed by a scientist called as Sommerfeld. In 1928, this scientist was proposed this theory. According to the theory, classical free electron theory, let us see how the failures of the quantum classical free electron theory was overcome. Now, according to this theory, not all the free electrons are responsible for electrical or thermal conductivity of a given metal. According to this theory, not all free electrons are responsible. Then which free electrons are responsible means those free electrons which are at Fermi level. Those free electrons which are located at Fermi level, they are only the responsible for electrical conductivity. Like this theory was suggested some changes in classical free electron theory, and that theory is called as quantum free electron theory. By assuming as like this, there are so many advantages are there. Some other things can also be explained about. Some other properties of metals can also be explained by assuming as like this. What are the successes of this theory? Now we will discuss. Successes of quantum free electron theory. If you take, by using this theory, we can explain the specific heat and the paramagnetic properties of metals also, which could not explained by using the classical free electron theory. Not only that, the temperature dependency of resistivity of metals can also be calculated or explained by using this theory. Successfully we can explain. And the thermionic emission of metals can also be explained successfully by using quantum free electron theory. And using this quantum free electron theory, we can also have another advantage, that is classification of materials can be done by using this theory. That is as semiconductors and insulators and conductors, we can classify the materials as like this. So this is about quantum free electron theory, that whatever the successes are there. Now if you take the failures of quantum free electron theory, none of the theory can be expected as 100% correct. Definitely it will have some successes and also will have some failures are also. Now if you take the failures of this quantum free electron theory, by using this theory we cannot explain electric specific heat and specific heat capacity of metals. This cannot be explained by using quantum free electron theory. And also by using this theory, superconductivity cannot be explained. If you want to explain about the superconductivity, nowadays we are using a theory called as BCS theory. It is a separate theory. By using that only we can explain about the superconductivity phenomena. Quantum free electron theory we cannot use to explain about the superconductivity of a metal. And very important thing is this theory unable to explain here also the photoelectric effect and Compton effect and the black body radiation. These three cannot be explained by using this theory. But very important thing is this theory is successfully explained about the electrical conductivity of conductors, and also why in insulators electrical conductivity is 0. But by using this theory we cannot explain why in semiconductors electrical conductivity is in between conductors and insulators. So to explain about the electrical conductivity of semiconductors, nowadays we are using a theory called as band theory. Band theory we are using to classify the materials as 3 different types. So this theory cannot be used to explain the electrical conductivity of semiconductors, but conductors and insulators electrical conductivity can be explained successfully. So this is about the failures of quantum free electron theory. Now conclusions. Overall we can say that both the theories are explained about the electrical conductivity of metals only. They were concentrated on metals, and electrical conductivity of these metals were explained by using these two theories successfully. And both the theories have failures and as well as the successes. And band theory in general is used to explain the classification of materials based on the energy band structure. As like that we can conclude. Thank you.